Welcome back. This is going to be about 3.2, and we are going to cover applying inequalities to algebra stuff. So in 3.1, we discussed general inequality review, right? We talked about number lines, graphing inequalities on number lines, the different symbols. We looked at some real world examples, but now we get into the fun of it, at least in my opinion. We get into how do we apply inequalities to algebraic situations. The beauty of this is we can solve inequalities the same way as we did algebraic equations. I want you to think back to chapter 2. In 2.1 through 2.4, we solved different types of algebraic equations. We went from 1-step to 2-step. We had variables on both sides to 2.6 where it was all variables. We're kind of going to do the same thing here with inequalities. So what do I mean by that? Well, if I wrote the equation down, x minus 3 equals 5, you all would tell me to get the variable by itself and figure out what it is. I would add 3 to both sides, inverse operations, and I would get x equals 8. Wonderful, Mr. Carter, we know how to do that. We just passed our test over that. Excellent. What I'm telling you is you could have the same thing for an inequality. We'll get into where in the real world you would see this later. But we could have the same thing with an inequality, and you're going to solve it the exact same way. Again, how do I get the variable by itself? That is my goal. Well, I'm going to add 3 to both sides. When I do that, I get x is less than 8. Now, this is not just a single solution, as we talked in 3.1. With inequalities, we will not have a single solution, but this is a set of numbers. What this means is any number less than 8 makes that inequality true. If you don't believe me, plug in any number less than 8 for x in the above inequality, any number less than 8, and see if it is less than 5. Okay? So the whole point of this whole lesson is going to be about applying algebraic situations with inequalities. Let's try another example. Say I have 12 is less than or equal to x minus 5. Again, I'm trying to get the variable by itself. Go ahead and pause the video, see if you can figure it out. Okay. What are we going to do here? Well, we want to get x by itself, and that pesky minus 5 is attached to it. So how are we going to remove it? Do our inverse operation. Add 5 to both sides, because what we do to one, we must do to the other. And I get 17 is less than or equal to x. Again, what is the context of that answer? What does that mean? 17 is less than or equal to x. It means any number I plug in greater than 17 in for x in the original inequality will make the inequality true. Again, please remember the open side of the inequality points to what is greater. So in this case, the open side is facing the x, which means any number larger than 17 satisfies the inequality. Okay, let's try one more example. X plus 5 is less than negative 7. And I want to get x by itself. The 5 is attached to it. So I subtract 5 from both sides. And doing this, I get x is less than negative 12. Negative 7 minus 5 is negative 12. If you struggle with those negative subtractions, try and do them on your own, but then check them with a calculator. So any number less than negative 12 will be the solution to my inequality. This is how we solve one-step inequalities or algebraic inequalities. We will get into more complicated ones in later sections. But for now, if you are confident with this, we're going to move on to some word problems. If you are not confident with this, this is a great point to pause the video and shoot me an email and discuss what isn't making sense. All righty. Time for some story problems, aka my favorite thing in the world. I love to call them story time with Mr. Carter because you all seem to hate it less when I do that. But regardless, we're going to do some real world problems here. So Mr. Carter owns a ski resort. Mr. Carter owns a ski resort. The maximum safe weight of a chair lift at my resort is 680 pounds. The weight of the person in the lift is 124 pounds, and the weight of the skis are 10 pounds. How much additional weight could the lift hold safely? Maybe we could imagine this is a 2-person lift. We're trying to see if we could fit another person on there. I digress. Let's figure it out. Well, remember, what do I say over and over again? Word problems are the same as the normal problems we just did. They just have the added step of we have to set them up. So how do we set this up? Well, let's identify our key pieces of information. The maximum safe weight is 680 pounds. The maximum safe weight is 680. We've got a person who weighs 124. And we've got some skis that weigh 10 pounds. We want to know how much additional weight the lift can hold safely. Well, as you know, in algebraic word problems, I always like to look for some sort of total first. Now, your brain's probably racking and going, okay, well, it says the maximum safe weight of the chairlift is 680. So that sounds like a good number for a total, and I would agree with you. So on one side of our inequality is going to be 680. Now, you just heard me say inequality, not equation. Why? Well, because I'm not necessarily trying to hit the 680, right? I don't have to equal 680. In fact, to be honest, I'd prefer not to be on the safe side. I am okay with anything at 680 or preferably under 680. So at 680 or under 680 should ring in your brain 680 or less. Therefore, when we think 680 or less, the open side of the inequality should face away or toward the 680. Why? Because that is the top number we are willing to go to. I'll explain more in a second, but if the open side faces the variable, that implies any number greater than 680 is okay, and that's certainly not what we want. We want everything under 680. So I'm going to have the open side face the number. Now, what is making up that 680 pounds on our chairlift? Well, we have 124 pounds. And we have 10 pounds of skis. And then we want to know how much additional weight we could hold. Do we know what that additional weight weighs? No, we do not. So we go ahead and toss in a variable for it. Again, the open side of the inequality needs to be facing the 680 because if it faced the side with the variable, that would imply that 124 plus 10 plus x had to be larger than 680. And of course, we don't want to snap a ski lift and all fall down the mountain. So what are we going to do here? Well, now that we have it all set up, we just need to get x by itself. So we can start by combining our like terms here. Get 134 plus x is less than or equal to that 680, or the 680 is greater than or equal to 134 plus x, however you want to phrase it. Now we're going to subtract 134 from both sides to get that x by itself. And we find out that 546 has to be greater than or equal to x. Did a little mental math there. Okay, 546 has to be greater than or equal to x. Final step, interpret it in the context of the problem. What does that mean, 546 is greater than or equal to x? That means the additional weight must be less than 546 pounds to be under the safe limit for the chair. So if I'm adding another person, they and their gear need to weigh less than 546 pounds. Okay? So let us keep going. Now, I've got another word problem here, somewhat similar. It's going to be another inequality hint. But I want you to try this on your own. I really do. I want you to pause the video right now and see if you can figure this out. Okay, so pause the video, give it a shot. All right. So whether you've completed the whole problem or you tried it and got stuck, I'm going to go through this in parts, and I'm going to ask you to pause the video at certain times. That way, if you got stuck, you can pick back up and keep trying. So Mr. Carter's baseball team has a goal of collecting 160 blankets for a shelter. Team members brought 42 blankets on Monday, 65 on Wednesday. How many blankets must the team donate to make or exceed their goal? So let's write down those key pieces of information. Maybe this is where you struggled. You feel good about solving the equation or the inequality, but you struggle with getting the key pieces of info. Well, you see I wrote down 160. Again, you know that I love to identify a total off the bat. We want to get a minimum of 160 blankets. Why do I say minimum? Because I want to make or exceed that goal of 160 blankets. So I've got 160 that is important. And then we have how many have already been brought in. We had 42 on Monday, and we had 65 on Wednesday. Okay? So if those were the key pieces of information, let's set them up in an inequality. Well, 160 is going to be some form of total. That is our minimum goal. Now, if it is a minimum, do I want the open side facing that number? No, I do not want the open side facing that number. Why do I not want the open side facing that number? Well, because if the open side faces that number, that means I can't have more than 160. And I want to beat my goal. I don't want to stay under 160. I want to have more than 160 blankets. So the open side needs to face away from that 160. If you are someone struggling with where the inequality faces, let me know so I can help you out. Okay, so the minimum we want to get is 160, so the open side faces away. What currently is making up that 160? We had 42 blankets on Monday. We had 65 on Wednesday. And we're trying to figure out how many left we need to get on Friday to beat our goal, or at least tie it. Again, key word, make or exceed that goal. Make is what allows us to put that equal to sign underneath the inequality. If it just said exceed the goal, it'd be strictly greater than. Okay, so if you struggle to set this up, that's okay. But I want you to pause the video now that we're set up and try and solve the inequality for x on your own. Okay, so you're back, you've paused it. Now you've solved it. Let's try and solve it together. Or you can check your work. I'm going to combine my like terms. 42 plus 65 gives me 107. My goal is 160. I will subtract 107 from both sides to get that x by itself. And I find that to make or exceed my goal, I need to get I need to get 53 blankets. 160 minus 107. 53 blankets donated on Friday to meet the goal. Again, you just heard me do it again. I interpreted my answer in the context of the problem. I don't just write x is greater than or equal to 53 or 53 is less than or equal to x. I know that that means that's how many blankets I need minimum on Friday. Or any number greater than or equal to 53 is an acceptable number of blankets to meet or exceed my goal. That's 3.2. If you have questions, as always, please let me know.